Okay, I got this 13-inch mirror, 13.1, so you know it's a Coulter. And I put it on the Ronchi, I put it on the bench and did a Ronchi test, and I compared it to, let's say, diffract. So at this time, I had a 100 line screen on, and I said, okay, let me assume that this is 0 and take a picture of it, and then I go through the focus to get to a certain distance so that I can compare it to a certain distance with diffract to see how it looks, right? And I don't have the screen on diffract, but on the mirror screen I have a wavefront error rating that I put on, and I adjusted it so that I could get close to at this as 0, let's say 8.23 millimeters away. It should look like that, and I measure it with my dial um, indicator, and that's what I got somewhat close to it. So I know that this is undercorrected because what the wavefront error reading I put on diffract program gives me those two figures that far apart. So I also tested it with a Rossnall lens, and then you can see, look, two lines. Let's try to get two lines here. Right there, you can see that it curves. That's not good when and this is inside of focus, so you know that's undercorrected. And outside of focus, look how that curves. It bows inside. Four lines, even with four lines, you can see. And outside, where is it? Okay, I'm back outside. Is it outside? Then go back inside to get the 2 or 3 lines. I like to try to do 2. And let me see if I could get a glimpse of it at focus. I don't know. Oh, look at that. Yeah, you can. There's maybe a zone right here, but we'll see. And then, I know it's undercorrected, so in the Rosnell program, I was able to like pull the lens back and enter in how much difference the lens is. Let's say I put in the program and say the lens is 1 inch further than it's supposed to be, or 2 inches further. Right here is 2 inches further, and this is, let me see, outside of focus right here. There's a little bit of tilt right here because it's near the edge and you can see a curve, but it doesn't curve here. And inside of focus, you can see it's opposite. It's bowing out, so that's like an overcorrected position. So I said, okay, I'm 2 inches away. Let me put it in about 1 inch. I didn't really measure. I tried to just push it closer. And let me see. This is outside focus, and this is inside focus, or either way, there. It was pretty straight. A little bit of bow, but that's pretty good. And at this point, you can see there's a tilt error. Look, straight, maybe curve down here, so it's a tip and tilt error. I would measure the distance from the mirror to the lens and put that into, let me see, the Ross Null. Let me see if I can get the program up. Where is it? I'll see if it fits on the screen. Where is it? So let me enter it in quickly. I go, this is 13.1, 13.1. This is 117.25, radius of curvature. Go back to millimeter. My lens is negative 207.6 and 6.9 thickness. 6.9. 80 millimeter. I like to do 5.2 for my LED. And let me go get an inch. And this is the figure that I set the lens to mirror distance. But I could go in here and go, okay, let me see if I set it at 1 inch away, what is my rating going to be? And at 1 inch, this is the normal setting right here. 1 inch right here, it gives me 0.5 waves, a half a wave, and 1 inch the other direction gives me a half a wave. So my roughly this mirror is a half a wave undercorrected. Alright, so and this is clear indication or else null. 2 lines, and then the other side. You always have to flip it because even here it looks kind of straight when I set it at 1 inch away from our optimal. And you can start to see a zone too. Look, a zone right here. See if I go through focus to see if I get a that zone pops out again. Alright, that's about it. Got some work to do.